Alright, it is day 23, and we're doing our turtle crossing capstone project. From what I've gathered, it looks like it's going to be a sort of Frogger style game, so let's go ahead and get on.
Hey guys, welcome to day 23 of 100 Days of Code. Now, today we're going to be building towards our second capstone project, and this is going to be a turtle crossing game. You might have played Crossy Road, so this is a similar concept. We have a whole bunch of cars going across a super busy multi lane highway, and our turtle is the player who has to cross the road. This is what the gameplay looks like. The player controls the turtle, which can only go forwards, and there's a whole bunch of randomly generated cars which are going horizontally across the screen. Now, once the player reaches the other side of the screen, the cars speed up, but the player goes back to the starting position, ready to cross the screen again. Now, at some point, when the player turtle hits a car, then that is game over. It's a pretty simple game, but it's going to test you on a lot of things that you've learned so far, including how to create classes, how to inherit classes, how to use the objects created from those classes, and also your knowledge of the turtle coordinate system and the turtle game engine. Once you're ready, head over to the next lesson where you'll find the starting code for this project, and also you'll be able to choose your difficulty level. So head over there and get started now.
Okay, um, start by downloading the turtle crossing. Oh, go ahead and extract this out to desktop. Turtle crossing. Yeah, I guess I'll just start a new project and okay, so we've got our main with our imports. Go ahead and open all of these up. Um, she's already got our screen started here, 600 by 600. Got our tracer set up. Cool, pretty standard first part. I don't think we need to watch this, but let's go ahead and
Now,
do it
hopefully you've
anyways.
already downloaded the starting project. So you can go ahead and click open in PyCharm, find the location where you've downloaded your Turtle Crossing start, and make sure that you've unzipped that zip file. And you've got the actual folder which contains all of the starting files. So select the folder and then click open. And we have to configure a Python interpreter and make sure that your Python interpreter is at a minimum of Python 3.8. So you can use 3.9 or above, but if it's lower than 3.8, you might get some errors and some problems. Refer back to when we first started out using PyCharm and when we installed Python if you get stuck on this. Now, if you take a look at inside our project folder, you can see I've already created 4 files for you. These files are pretty bare bones, but if you take a look at the main.py file, which is your starting point for your program, you can see that I've written a little bit of code that we learned about in previous lessons. So we've created a screen object and we've set up the screen to be 600 by 600 pixels. And then we've turned off the tracer by doing the tracer 0. And instead, we're getting the screen to update every zero point 0.1 seconds. So within the while loop, the code is going to run every zero point 0.1 seconds. So whatever it is that you put inside this while loop, it's going to be refreshed every zero point 0.1 seconds. Now you'll also see that I've imported some classes from these files: player, car manager, and scoreboard. Now inside these files, I've created the starting point for each of the classes. The player class is going to be the turtle which we're controlling to cross the road. The car manager is going to generate all of the random cars and move them across the screen. And then the scoreboard is just going to write the level that we're currently on and also the game over sequence. Now, inside each of these classes, I've got pass written here just so that the linter will stop screaming at me. So as we mentioned before, Python doesn't like things that are empty. So empty functions, empty classes, and you'll get these errors. Instead of getting these errors, all I've done is simply written pass, which essentially just makes this an empty class. So when you're creating these classes, just delete the pass and you can create it as you would normally. Now, in addition, we've got all of these constants in here. For example, the starting position of the player turtle, how much the turtle should move each time, and where the finish line is on the y-axis. In the car manager, we've got the colors of the cars, we've got the move distance of each of the cars on each refresh, and we've also got how much the move distance should increase every time the user levels up. Finally, we've got the scoreboard, which just contains the font that you're going to use to write out the scoreboard. That's pretty much an introduction to the starting file. So once you're ready, feel free to head over to the next lesson and get started with each step of the game.
Okay. I don't think I really want to look at this right now, so we can go ahead and um, well, actually, just to be sure, expert only use step one, so we do need at least step one. Okay. Alright, a turtle moves forward when you press the up key. Um, can only move forward, not back, left, or right. All right. We can go ahead and open up our recent. Let's do Pong. Do a new window. thought I needed random in here somewhere, but it says it's not in use. Anyways, not part of the issue. Let's get our um, I like to call things my, so um, gonna need our exit on click, can't forget that. She doesn't have an actual, I mean, I guess we don't need an actual turtle class, so um, if I can throw it on in here. Oh, Tortuga equals turtle shape. Wait, no, need to change that as well. To color, we'll do the usual green, even though most turtles are not actually green, but Tortuga dot move up. That's right. We can just do Tortuga dot heading is 90. Did not like that. I also want to change this to up. Um, 2.pen up and go to 0, 280. Cool. That's the issue. I did not put how far. I think I'll 20. Maybe we do have to define. Gonna need a different example. Maybe this one. Yeah, I can. Okay, so she does have. I wasn't even thinking. This is where we're putting all of our turtle stuff. So take this out. self dot forward equals move distance. So that's why she didn't have turtle there. Alright, well, at least that works. Um, cool. Okay, what's the next step? Cars are randomly generated along the y-axis. Okay, so we'll need the same sort of stretch code for this as we will for our car. Now, give me, I don't think we need our Etch-a-Sketch anymore. This will also take turtle. Self dot color will be rand choice colors. Self dot set heading to 180. Self dot pin up, self dot is going to be 300. Let's do 315 on the x-axis and rand int anywhere between negative 275 to 275. Um, Derive, that will be self dot forward. Probably want to self dot shape square. Yeah, okay, so just like the ping pong or pong paddle, what we need instead is to set the width to just see how this changes. Let's do 2. That might be what we're looking for. Heck yeah. Okay. I want to do a loop to create the cars. trying to think of how to automatically create the cars without it getting too crazy. Yeah, I guess we can just, instead, we'll go ahead and self.drive. That way we can take this out of there. I don't think she's generating one every zero point 0.1 seconds. That would be way too much. Wow, true. Uh, random number equals rand int 1 to 20. Let's do 1 to 10. want it to go negative. No, never mind. I got these backwards. We want it to be new x. Solve dot y. Okay. Why are they not moving? So I understand that it's only doing the drive once. Um, so how do we get the pong ball to always move? We need to leap through cars, and reach car and cars. Car dot drive. There we go. Oh boy. We made it. Make it even harder. Did it. Cool. Alright. Well, what's the next step? And the turtle hits the top edge of the screen. Okay. So we need to uh, take a look at our Pong here. And what we looked for is if, so we can do a Y core similar to this down here. If Tortuga dot Y core is greater than or equal to 300, we can do 290, right? That should be good. Um, Scoreboard plus equals 1. Tortuga dot go to. Do finish line y times -1 for that. Oh, it was there all along. I don't even know if we want that there. Yeah, no, I'm just gonna cut this out and we can move it to main. I still want 290, yeah. Finish line. Yeah, we can do our own. Define start position. Go to start self dot go to Station. Go to start. I guess we do take turtle. Define initialization super self.color. I want that to be black because we got a white background. Yeah. Self.pen up. Self.score equals 0. Do I define draw? Nope, that is not what I meant to do. Self.clear. And where do we want to go to? I think alright, so it'll be centered on because we just need level colon and then the actually I guess we should do level anyways, right? Level equals 1. This we can go to negative, let's do 250. Probably not far enough, but we'll see. And then a y of 280, 285. We'll do self.write, do an f string, score, or level, self.level, line equals center, font equals font, player score, self.level plus equals 1, draw scoreboard, and we also want to we'll keep the player score and the increase speed separate. It's a bit off. A little too far to the left, so we want to bring it back. Try that. Nearly. Cool. Um, but that being said, we need to decrease the range that they can. Uh, yeah, let's do 250 to 250. That may or may not have been a hit, but cool. To my scoreboard dot player score. Okay, now let's do our collision logic. If Tortuga dot distance, yeah, let's include all of this since we're already using this for loop for the cars. If Tortuga dot distance car is less than, let's call it, split the difference, 12. Guess we need to do a define reset scoreboard. go to and yeah, I guess we can just draw self dot draw scoreboard. Yeah, I like that. Alright, now let's get hit by a car. Hmm. Everything's working except for the car collision. I think. Okay. So maybe I just wasn't actually even looking at the score or level. That's a close one. Get hit. Cool. Um, Now I know they have a game over option, but I think what I'm going to do is implement lives. So we can also do a self dot lives equals 3. Define lose life self dot minus equals 1 self dot draw scoreboard. I mean, we're already going to be losing a life every time we reset the scoreboard anyways, so might as well just put these all together. And then let's look here to remember how to... Okay, this is how we write multiple self dot go to, and we can just do 200, the exact opposite. What the heck? 255. Self dot rate. So I'm thinking about doing like a list instead of just doing lives equals the numerical 3. I kind of want to do 3 turtle objects. Um, no, I don't. For in range self dot lives. I don't think I can just do a self dot right. This is definitely not going to work, but yeah, that may be a little ambitious for my experience, so we can just do lives, self.lives. Okay, excuse me, you are correct. I had that out of order. And we're gonna get hit by a car, hit by another car. Cool, that all works. Alright, so we just need to uh, increase car speed, reset car speed, and I think that might be it. Fine, increase, and let's just accelerate. Self dot, so I'm looking at drive, and we have our distance. I'm entirely unsure why we have move increment. But I think we actually want starting move distance. And then so close, or so close yet so far. Because I'm not sure what she has the move increment for. Hmm. How do we get this to Yeah, let's do a self.speed. I think we can override this. Current speed equals self.current speed. And this will be self.current speed plus equals move increment self.drive, and then reset speed self.current speed equals in cars car dot reset speed. Where is here? For each car in cars car dot accelerate. Now if my scoreboard dot lives equals 0, we also need to scoreboard dot we did do a lose life, right? Okay, let's do define lose life self.lives minus equals 1. Game is on equals false. And how did we get it to say game over? I don't think we did in this one. I think it was the snake. There we are. think it might be as simple as that. Alright, let's give it a try. That is a lot of cars. We're gonna speed up a whole lot. It looks like they only sped up for a little bit though. Alright, now let's lose our life. Alright, that was 2 lives lost, okay. Alright, there's something calculating our... Okay, so that's why. Go ahead and take this out. Try it again. Obviously, cars don't overlap on the street like this, but cool. Lost a life and went back to level 1. Let's boom and boom. Game over. Everything stops. Um, Now, considering I still want to just watch through all of the tutorial videos that she has, um, and we're already at an hour and a half, I'm just gonna tweak the speed acceleration for the cars off camera after this is all over. And other than that, though, I'm pretty happy with all this. So let's see what she has for us. Yep, yep. Break it all down. So,
Alright, so just as previously, we've split up this large problem of building the game into 5 smaller subparts. Firstly, moving the turtle, controlling it with the key press, creating and moving the cars automatically across the screen, detecting a collision with the car, and detecting when the turtle reaches the other side. Finally, we create a scoreboard that keeps track of which level we're on and also that shows game over at the end. So the first step is to move the turtle using a key press. The turtle can only go forwards, and every time we hit the up key, the turtle moves forwards by a set amount until it reaches the other side of the screen. This is the first thing that we're going to tackle. Now, because this is related to the functionality of the player, let's go ahead and create this inside the player class. I'm going to delete that pass, and I'm also going to import the turtle class from the turtle module. Now our player is going to inherit from this turtle class. So inside our init, we're going to need to add the super.init, or you can add it automatically using the light bulb. So now this player class can do everything that a turtle class can do, and we can make it do even more. The first thing we're going to do is we're going to set the shape of our player, and we're going to set it to a turtle. The next thing we're going to do is we're going to call pen up so that this turtle just remains a shape and it doesn't draw. Finally, we need to get it to the starting position and get it to face north. We can do that by setting self.goto, and then we can set it to go to the starting position, which you can see is a tuple because it's enclosed inside parentheses and you've got values separated by a comma. Finally, we're going to set the heading of our turtle so that it faces north, which is 90 degrees. So now all we have to do is go back into our main.py. After we've set up our screen, let's go ahead and create a new player from the player class. Let's go ahead and run this code. And you can see that we've got our little turtle showing up here at the center of the bottom of the screen, and it's facing north. So now the next thing we need to do is to get that turtle to move upwards every time we hit the up key. That means we're going to need to get our screen to listen for events. After calling screen.listen, we're going to get the screen to listen to a keystroke. So we can use onKey to set the up key as the key to listen to. And then when that happens, then we're going to call player.goUp. And remember that when we're calling methods inside the listener, we don't want to add the parentheses because this will trigger it at the point where it evaluates this line of code. Instead, we want to trigger this function only when this up key is detected. So now all that's left to do is to go into our player.py and define that function goUp. So how can we move our turtle up? Well, we can get our turtle, so self, and then we can get it to move forwards by a distance. And the distance is going to be the move distance that's set in this constant here. This means that later on when we want to change the move distance, if we want it to go further each time, we can just edit it at the top of the file instead of digging through the code. Now let's run our code again and let's just make sure that it works. So now every time I hit the up key, my turtle moves up and it keeps on going until it reaches the other side of the screen. So that's the first step completed. Now, if you think you can complete the next step by yourself, then head back to that list of problems broken down and see if you can tackle the next one by yourself. If you can't, or if you need some extra help, then you can always come back to the videos and I'll walk you through the steps one by one. In the last lesson, we managed to figure out how to get the turtle to move with a key press. And that's with every press of the up key, the turtle moves further towards north. Now, the next task is to create and move the cars. The cars need to move from right to left, and they need to be randomly generated along the y-axis here. So they need to be generated right to the right edge of the screen, and they can appear anywhere along this line, and then they're going to move automatically towards the left at a fixed pace. Each of these cars, you can see, are going to be turtles, and they're going to be 20 by 40 pixels. So we mentioned that by default, every turtle that we create is 20 by 20 pixels. So we'll need to stretch the turtle to make it into this shape. Now that we are concerned with the cars, let's create our code inside the car manager. The first thing we'll need to do is to import the turtle class from the turtle module, and our car manager is going to have a init where we create all of our cars. So I'm going to create a list called all cars, and it's going to start out being an empty list. Now, at some point, our main.py is going to call a function from the car manager called createCars. And this method is going to create a random car somewhere along the y-axis with a given dimension. Each of these cars, so let's call it a new car, is going to be a turtle object, and it's going to be created in a square shape. Now, in addition, we're going to have to change the dimensions of this turtle, and we're going to use that method that we used before, which is this one, shape size. Now, what shape size allows us to do, if you remember, is it allows us to stretch our turtle along the width and along the length. So we want the width to be double the original size, so 2 times 20 pixels is 40 pixels. And the length we don't want to be stretched at all, so we're going to say it's 1 times the original length. In addition,
The
our
exact
new
opposite
car
worked
is not
perfectly
going to
for me,
draw,
so
so we're going to get it to pen up. And also, our new car is going to have a random color. So we can set the color and then we can import the random module so that we can use one of these colors in this list. And we can say random.choice and then pass in our list of colors from this colors constant. Finally, we're going to define where it's going to go on the screen. To do that, we need to define a random Y position. So this again is going to be created from the random module, and we're going to use the randint. And then we're going to define somewhere along this y-axis, which is the vertical, somewhere for this car to be generated at. So we know that our screen is
just
600 by
put it in there
600.
for the go-to
So that means the
method.
y-axis goes from positive 300 to negative 300. But we don't want the car to be generated all the way to the edge, because remember, the turtle needs a bit of starting space and also a bit of ending space. So you can play around with this number, but I've ended up going with minus 250 to positive 250. This means that we get a good range in the middle of the screen, and that the turtle has a bit of empty space at the beginning and also at the end when it needs to move across. So now that we've defined our random Y, we can tell our new car to go to the X position, which is going to be the very edge of the right screen. So that's going to be positive 300 right to the edge. And then the Y position is going to be the random Y that we just created. And finally, once we've created our new car, we're going to append it to our list of all cars, which of course, because it's defined in a class, it has to have the self in front of it. So self.allcars.append, and then we're going to append this new car that we've just created. Now, coming back to our main.py, let's create our car manager from the car manager class, and then we're going to use it inside our game loop here, so that on every refresh of the screen, every 0.1 seconds, we're going to get the car manager to create a new car. And strictly, this probably shouldn't be plural, because each time we call this method, it only creates one new car. So let's change that method so that it only creates one car, but it creates one car every 0.1 seconds. Now, at this
Yeah,
point
that
in
sounds like
time,
a lot.
if we run our code, you'll actually see nothing happen, because the cars are being created at this right edge here, and it's not yet visible on the screen. To make it visible, we have to move our cars across the screen. Let's create another method which we'll call move cars, because this method is going to go through our list of cars, so for car in self.allCars, and for each of those cars, it's going to move it towards the left by the move distance that we've defined up here. So to do that, all we need is to get the car to move backwards by the starting move distance. Now it's going to loop through our list of all cars that were created, and then for each of the cars, it's going to move it backwards by 5 paces. So now, in addition to getting the car manager to create a new car on every refresh of the game loop, we're also going to get it to move all of the cars by 5 paces.
It was a bit
Let's hit
cleaner than what
run
I did.
now, and you should see that we've got our cars being generated, but notice how I've made a slight error in the stretch. Instead of stretching it along the length, I've stretched it along the width.
That's a
And
ton
this
of
is why
cars.
we've got this random array of shapes moving. So let's go back to our car manager and change the width to stretch by 1 and stretch the length by 2. So now if we rerun our code, you can see the cars are now the right shape, a rectangle that looks like it's moving to the left. Now, notice how in my case, the cars are being generated far too frequently. We've got way too many cars, and it's impossible for our turtle to cross the road. So we need to figure out a way of how we can reduce the number of cars that are being made. Instead of creating a car every zero point 0.1 seconds at every refresh of the game, we need to slow this down a little bit. And one way we can do this is by using a random number. Let's say that we create a random chance, which is going to be a 1 in 6 chance. So it's almost like throwing a dice. If you get a 1 on the dice, then we create a card. We can do this by getting hold of our random module, creating a random int between 1 and 6, and then we can say that if the random chance is equal to 1, then and only then do we actually create a new car. So this basically ensures that every 6 times the while loop runs, a new car will be generated. Now, it's not going to be precisely every 6 times because there's some degree of chance involved. But notice when we run our program now, see how the cars are now being created much less frequently. And we've actually got some space for our turtle to cross. So that is how we create and move our cars across the screen and make sure that they don't occur so frequently that our turtle has no chance of crossing the road. I hope this walkthrough was helpful. Don't worry if your code doesn't look the same as mine. It doesn't have to. What matters is if you're able to achieve the desired functionality of the game. There are a million different ways that you can solve this problem, and as long as it works, whatever way you choose will be the best way.
I definitely should have done the car manager more like she did, but
Now, in the last lesson, we created these rectangular cars randomly along the y-axis, and then we managed to get them to move across to the left side of the screen. The next step is to detect when the turtle collides with the car. So that way, when the turtle hits one of the cars, we can stop the game and prevent further cars from moving. Inside our while loop, I'm going to detect the collision with the car here. So I'm going to get hold of all the cars in the car manager object, and I'm going to use a for loop to loop through each of the cars in that list of cars. And then we're going to detect whether if the car has a distance to the player object that is less than 20. Remember that our cars are 20 pixels in height by 40 pixels in width. If the player is less than 20 pixels from the center of the car, then it probably means that it's collided with the car. So if this distance is less than 20, then we're going to stop the game. And the way that we stop the game is, of course, by turning this game is on from true to false. Let's run our code again and let's see this in action. So we can move our turtle, we've got randomly generated cars moving across, and let's just park our turtle right here. When that car hit our turtle, it immediately stopped the game. Now, if we want to take a look at what's happening, so for the screen to stay open instead of closing once the process is finished, we can tell it to exit on click. So now let's run our code again, and notice this time if we collide with one of the cars, you can see that it stops and it waits for further instruction, which eventually is going to be just the game over text showing up on screen and also the final level showing up on screen. That's it. That's how we detect collision between the car and our player.
Alright, abrupt ending.
In the last step, we figured out how to detect when the player turtle hits a car and to stop the while loop, which stops the game at that point. Now we're going to figure out how we can detect when the turtle reaches the other side of the screen, so that once our turtle makes a successful crossing, then we can return the turtle to the starting position and speed up all the cars. So I'm going to do that right here, and I'm going to detect a successful crossing. So what is a successful crossing? Well, the player turtle has to reach the finish line, right? Which we've defined the y value for as 280 here in the constant. Now, you could do this in a number of ways. You could define a method here, or simply just get hold of the player's position and then figure out if it's over 280 inside our
Pretty sure that's
main.py.
what I did.
Now, I'm going to create a method here instead. And I'm going to call the method is at finish line. This method is going to return true if the turtle is at the finish line and false while it's not. So how do we detect this? Well, we can get our self.y coordinate and we can see if that is greater than 280, which is our finish line y value, well, that means we've pretty much gone over the finish line, right? So if this is the case, then we're going to return true. But while that's not the case, any other time when we check this, we're going to return false. So now coming back to our main.py, we can call our player.isAtFinishLine, and we can say if this is true, well, in that case, we're going to get the player to go back to the starting position. So inside our player class, let's create yet another method, which I'm going to call goToStart. And this just involves getting our player to go to the starting position, which we've defined here in a constant. So notice how we've got a little bit of repetition here, so we can actually delete this line and simply call self.goToStart. Back in our main.py, once the player is at the finish line, we're going to get the player to go to the start. And if we go ahead and run our code as it is right now, you can see that once the turtle makes it across the road, it goes back to the starting position. Now, the very last thing we need to do is to increase the speed of the cars when the player reaches the other side, because effectively they've just gone to the next level. What we can do is when the player reaches the finish line, we can get the car manager to increase the speed of the cars. Let's create a method inside our car manager class, which we'll call level up. And in this method, we're going to get the car's speed to increase by 10 every time. So if we have a attribute called car speed, and we initially set it as the starting move distance, and then we use this car speed to determine how far it should move backwards each time. Well, then when we level up, we can say self.carSpeed now increases by the increment that we've defined here, which is the move increment. So now when our player reaches the other side at the finish line, then in addition to getting the player to go to the start, we're going to get the car manager to level up our cars as well. So now when my turtle reaches the other side of the screen, not only does the turtle go back to the original position, but the cars also increase in speed. In the last lesson, we figured out how to detect when our turtle reaches the other side of the screen, and when this happens, we return the turtle player to its original position, and we also increase the speed of the cars by the move increment that we defined as a constant. So in this lesson, what we're going to do is the final step, which is to create a scoreboard that keeps track of which level the turtle player is on, and also when the turtle hits one of the cars, to display the words game over in the center of the screen. To do that, we're of course going to go inside our scoreboard class, and again, we're going to need the help of the turtle class. So let's import that from the turtle module, and I'm going to make my scoreboard a subclass of the turtle class. So it's now inheriting from the turtle class. And once we've defined our init and managed to get it to inherit everything from the superclass, then our scoreboard is now able to do everything a turtle class can do. What do we want it to do? Well, we have to initialize it with a couple of things first. For example, we probably want to start out by hiding the turtle. We just want to use it as a pen to draw. And in addition, we don't want it to move and draw, so we're going to pull the pen up. We're going to be using the write method instead. And what we want to write is the level, right? So the current level that the player is on. In order to do that, we also have to keep track of the level. So let's go ahead and create a new attribute, which I'll call level, and let's start at level 1. So then we can insert this right here with self.level. And in addition to writing this text, we can define what we want the alignment to be. So I want this to be on the left, and also what the font to be. So I'm going to use this font that was declared up here as a constant. Now inside our main.py, next to where we've defined our player and our car manager, I'm going to create this new scoreboard object. And that's going to be created from the scoreboard class. Now notice when I run the code as it is, you can see that our level is left aligned. It's got the font that we defined and it's writing the text that we want, but is not in the right position. To define the position, we have to do that right before we tell the scoreboard to write. So right here, but after where we've got our pen up. So this way we don't draw a path to where we're going to. So now we're going to define self.goto, and I'm just going to get it to go to probably the top left corner. So that's going to be probably minus 280, and then it's going to be positive 280 on the Y. Now if we just check the positioning, you can see that it's a little bit too far up on the Y-axis. So let's move it down a little bit, and you can tweak these things until you get to the point where you're happy with its positioning. So I think this looks pretty good. Now, in addition to writing the level, we actually have to update it every time the player levels up, right? And they do that when there's a successful crossing. So at some point here, we should be able to call scoreboard, and we should be able to get the scoreboard to increase the level. So let's go into scoreboard and let's define that function, increase level. And the first thing to do when we're increasing the level is, of course, getting hold of this self.level and then adding 1 to it each time. In addition, we're going to need the level to be rewritten again. So let's cut this out of the init and let's instead define a custom method which we'll call update scoreboard. Inside this update scoreboard, we can write the current level. So now inside the init, we can call self.update scoreboard, and also when we increase the level, we can call self.update scoreboard. Now at the moment, as it is, it's going to overwrite what used to be on the scoreboard. So at the moment, it's on level 1. But once I make a successful crossing, you can see that level 2 is going to be overwritten over level 1. To prevent that, when we update the scoreboard, we have to get the scoreboard to clear itself so that it deletes all the previous stuff that it wrote. This way, when we actually run our code, you can see that our scoreboard will refresh and clear the previous text and write the new text each time. So now the final thing to do is to write the words game over in the middle of the screen when the game ends. To do that, I'm going to create another method here, which I'll call game over. And inside this method, we're going to get our turtle to go to the center. So we're going to say self.goto, and the center is of course at 0, 0. And then we're going to get it to write. But this time we're not going to write the level anymore. Instead, we're going to just write the words game over in all caps. And I want the alignment to be centered, and I want the font to be the default font. Now, when we actually detect a collision, not only is game on going to be false, but also we're going to get the scoreboard to show the game over sequence. So now we can run our code, and you can see that when my turtle collides with a car, then it says game over in the center. And because when we wrote game over, we didn't clear any of the previous text, the user can see the highest level that they managed to reach. That's it. That's the entire game. Hopefully you've managed to build this entire game by yourself, and you're just here to check a few niggling issues. But if you struggled with this code, then I really recommend to review the previous lessons where we created the snake game or when we created this turtle crossing game, and try to see if you can create these two games from scratch by yourself by looking at how the game works. Because if you continue forwards, things are only going to get more complex, and I'm assuming that you're going to take the time to review and revise before you continue. So have fun playing with the Turtle Crossing game, and be sure to let me know in the Q&A what your highest level is that you managed to reach. And also remember to attach a picture or it didn't happen. And this is a great project for you to customize. So think about what you might want to change, like the colors or the shapes, and make the game really your own. And then take a screenshot of it and share it with us in the Q&A so that we can all appreciate and congratulate you on your work. Hey, well done on completing day 23. Now, today I want to talk to you a little bit about the course. Because when I designed this course, when I thought about what was going to be in it, how I would record it, how I would structure the curriculum, one thing that I was really clear on is this shouldn't be a programming course. It shouldn't teach you just syntax or, something that you can read in a book. I wanted this to be a course on thinking. And that's why throughout the course, there are so many places where I ask you to pause the video to complete the challenge, or complete the coding exercises, or to build the projects. It's because the hard part of programming is not writing out the code. Very often, you're just typing out 10 lines of code, right? And once you see the solution, anybody can write it out. The hard part is the thinking. It's the breaking down the problem to smaller pieces that you can tackle one by one. It's coming up with the flow chart of the program, how it's going to work, how the logic is going to be. And doing that and getting repetition in doing that is really how you're going to succeed as a programmer. So I want you to make sure that every opportunity that comes up for practice, you take it. And you take that opportunity to think through the problem, break it down, understand it, and write your own code. Keep in mind that the coding part, the writing part is not important. The important part is the thinking, and you will be miles ahead of everybody else.
All right, cool. Um, we well, I just have to go back and change my car manager. I did like the way that she did it, where she just had the list and then creating cars was a little bit different. Well, the car list and then the current speed or whatever it was. So I'm gonna just change that up. Um, but we are at the 2 hour mark. Um, this was a pretty good all-encompassing capstone project for the whole what we've been doing now for a week with the turtle module. So yeah, we're almost a quarter of the way through the course. So hopefully should be some fun things tomorrow, and maybe I'll see you then for it.